Welcome to video lecturing on BSc first semester mathematics on matrices. This is session 18. In this session we are going to study about the system of non-homogeneous linear equations, consistency criterion for system of non-homogeneous linear equations. The learning objectives of this session was system of non-homogeneous linear equations, consistency criteria, criterion for the uniqueness of the solution. First, let us see about the system of non-homogeneous linear equations. That is, if at least one of the values on the right hand side of the equations a11x1 plus a12x2 plus etc. up to a1n xn is equals to b1. Similarly, a21x1 plus a22x2 plus etc. up to a2n xn is equals to b2. Like this, we have m equations in n unknowns. That is, the mth equation is am1x1 plus am2x2 plus etc. up to amn xn is equals to bm is non-zero. That is, if at least one of the RHS of these equations is non-zero, then that is at least one of b1, b2, b3 etc. up to bn is not zero, then system of equation 1 is called the non-homogeneous linear equation. And this system of equations can be written in matrix form as here Ax is equals to B, where A is a coefficient matrix that we have seen in the last session. A is the coefficient matrix of these systems, that is A is equals to A11, A12 etc. A1m is equals to B and second row is A21, A22, A23 etc. up to A2m, and lastly the last row is AM1, AM2 etc. up to AMN. And X is the matrix of unknowns, it is a column matrix x1, x2 etc. up to xn, and B is the matrix of RHS, that is it is a column matrix again, m by 1 column it is b1, b2, b3 etc. up to bm. This we have seen in the last session also. So in the first session, in 16th session, we have seen this one, how we can express this matrix in this system of equation matrix form. So next is consistency criterion. To check the consistency of the given system Ax equals to B, we have to first form the augmented matrix, that is A colon B. Here A colon B means A is the coefficient matrix and colon B means here B is the RHS coefficients, that is RHS elements, constants in the RHS. That is A11, A12 etc. up to A1n colon B1. Similarly, second and third row etc. up to mth row. That is, this is the matrix obtained by combining the coefficient matrix A and the column matrix B separated by colon. We have one theorem in this. The necessary and sufficient condition for the system Ax equals to B to be consistent. That is, consistent means to have a solution. That is, possesses a solution is that rank of A is equals to rank of AB is equals to R. If rank of A and rank of AB both are same, then only it has a solution, otherwise it has no solution. That is, A and A colon B must have the same rank R. Let us see how we can solve this one here. We use how we use this one to find the rank of the matrix. This is a solution of this matrix consistency criteria to solve the examples. First, let us take step 1. Step 1 is, first you have to form the augmented matrix A colon B. Then apply row operations, only row operations to reduce A colon B into echelon form. That is, this second step is to find the rank of the matrix. Then we know how to find the rank of the matrix, that is the number of non-zero rows. That is, we have to count the number of non-zero rows in both A colon B and also in A. That is, while finding the rank of this matrix A, you have to leave that colon, after colon elements you have to leave here. Consider only matrix A here. So to get rank of A and rank of AB. And fourth step is, if rank of AB is not equal to rank of A, then conclude that the system is inconsistent. That is, it has no solution. And if rank of AB is equal to rank of A is equals to n, where n is the number of unknowns, then conclude that the system is consistent and has a unique solution. This step is very important. If both the ranks are equal to number of unknowns, then we have only unique solution. And second one is, if rank of AB is equal to rank of A, which is less than the number of unknowns, then the system is consistent. Again, it has a solution and has infinite solution. This we have studied in the previous session also. And lastly, if the system has here if rank of AB, this I have not written in this third one only. So if both the ranks are not equal, then only it has then it is inconsistent. It has no solution. So in the last step is reconstructing the system of equations using the final form of A colon B and solve the same as we have done in previous cases. Let us take one example in this. Verify the system x plus y minus z is equals to 1, 4x plus 4y minus z is equals to 2, 6x plus 6y plus 2z is equals to 3 for consistency, and hence solve. Take solution. The augmented matrix is A colon B. It is equals to the matrix form. You have to write the coefficients of x, y, z in the first equation, similarly second and third equations also. Here again, as you have seen, we have to find the rank of the matrix. Again it is repeated. I will not repeat the same thing here. You have to make here, what we have to do is you have to make this element 0 and this element 0 in first step. So for that we used here, we have changed R2 changes to R2 minus 4R1 and R3 changes to R3 minus 6R1. So you will get these two rows as I have explained in the previous session. So next one is here. Again we want to make third rows also 0. For that we use here, as we have seen here, third row we want here also 0, no? This 8 we want 0. This 8 we want 0. To make this one we have to use here operation. This is again what we have done here. We have R3 changes to, this is 3 times of R3 minus 8 times of R2. You will get this one here. This third row is equals to 0 and here we will get some element here. So what this implies here? This implies rank of this so this implies here rank of A colon B. Rank of A colon B means here, while finding the rank of A colon B, you have to consider this whole matrix. You have to consider. Here there are how many non-zero rows? Here we have 3 non-zero rows. So this implies the rank of A colon B is equals to 3. And rank of A is equals to 2 you will get here. While finding the rank of A, you have to consider only this much. You have to consider only this much. So in this what we have here, we have third row is equals to 0. This row is 0. Therefore there are how many non-zero rows in this? There are only 2 non-zero rows. Therefore rank of this A is equals to 2. This is the concept. So this implies here rank of AB. This implies here rank of A colon B is 3 and rank of A is 2. From this we can say that here these two ranks are not equal. Hence the system is what? System is consistent. Hence the system is here consistent. So it has no solution. Let us take one more example. Verify the system. 2x plus 4y plus 4z is equals to 2. 3x plus 2y plus 2z is equals to 3. 2x plus y plus z is equals to 2 for consistency, and hence solve. First you have to write the augmented matrix is. Here the augmented matrix is like this. That is the coefficients of these equations. Next is, again as you have done in previous cases, you have to find the rank of this matrix. So first you have to make R2 changes to 2R2 minus 3R1, R3 changes to 3R3 minus R1. So you will get this second row, and third row is R3 changes to R3 minus R1, you will get here third row. So again, what we have done here, we want here, we want this one, the second row we want 1 because both are 1 1, and third row is also minus 3 3 3. So what we have done here, we have done R3 changes to 1 by 8 times of minus 1 by 8 times of R2, and R3 changes to 1 by 8 minus 1 by 3 times of R3. So we will get here, divide the second row by minus 1 by 8, you will get 1 1 1, and divide the third row by minus 1 by 3, you will get here divide by 1 by 3, sorry not divide, it is dividing by minus 3 it is, or multiplying by minus 1 by 3. You will get third row as 0 1 1 1, and this definitely it is also equals to 0. So what we get here, we will get like this. Then we can make here third row 0 by applying row operations. So that is R3 changes to R3 minus 2 or R3 minus R2. Here we have these two rows are same. So if you just subtract these two rows, you will get here R3 changes to R3 minus R2. You will get 0, 0, because here 1 minus 1 is 0, 0 minus 0 is also equals to 0. Like this you will get there this matrix. So now this implies here, what this implies here, so rank of this matrix A, this is this much. Rank of the matrix is how much here? 2, because there are 2 non-zero rows. And what we have here, rank of A colon B. While finding the rank of A colon B, we have to consider this whole matrix. So in this, how many non-zero rows? Here also we have here, this third row is again 0. Therefore here also there are only 2 non-zero rows. Therefore rank of A colon B is also equals to 2. So this implies here rank of A colon B is 2 and rank of A is also equals to 2. And these two are equal. These two, rank of A colon B is equals to rank of 2, and it is less than 3. Why it is less than 3 means here, why have to take only 3 means the number of unknowns. We have here 3 unknowns x, y, z, no? So it is less than the number of unknowns. We have seen this one in previous slides. That is, if rank of A colon B and rank of A both are same and it is less than the number of unknowns, then we have infinite number of solutions. Then you have to write the equations, that is from the final form of matrix A colon B. What we can get here is the this one. In this previous slide we can see here, we can write using this one, we can write the equation for this one is here 2x plus 4y plus 4z is equals to 2. This is equation 1, and from this row we can get the equation as x is 0. So no need to write this one, y plus z is equals to 0 you will get here. So these two equations you will get. We have 2x plus 4y plus 4z is equals to, take this one as equation number 1, and the second one is y plus z is equals to 0. This is second equation. So from second equation we can say here, we'll get y equals to minus z here. From second equation we will get y equals to minus z, and equation 1 gives here, from this equation 1 gives 2x is equals to, take all the terms in RHS, it becomes 2 minus 4y minus 4z. So what this implies here, from this we can say here all the terms contains 2. We can divide this whole equation by 2. You will get x is equals to, dividing this equation by 2, you will get x is equals to 1 minus 2y minus 2z. So here what to do is, here you have to substitute the value of here y. We have y is equals to minus z, substitute in this. Here y is equals to minus z. This I have taken bracket here, but it has not appeared in this. So it is 2 into minus z it is. So it is 2 into, this is x is equals to 1 minus 2 into y. Y is minus z. This one is 2. 2 into minus z, then minus 2z. So it becomes what here? This is minus to minus plus 2z. No, it is. So it is. This implies here x z is equals to, y is equals to minus z. No, minus into minus plus, and this one is minus. This is plus 2z and minus 2z. These two get cancelled. You will get here only 1 remains. So this is x is equals to 1. This is, you will get only x is equals to 1. So on choosing here, we cannot get remaining values. So because here we have only 2 equations in 3 unknowns, definitely have to choose one value arbitrarily. On choosing z is equals to k arbitrarily, we have here, this one is, we have x is equals to 1 is there, and y is equals to, we have what here, y is equals to, we have minus z. So we will get here y is equals to minus k, because we have chosen z is equals to k and z is equals to k is the required solution. So what we have here, we have x is equals to 1, y is equals to minus k, and z is equals to k is the required solution. Let us take one more example. Check the consistency of x minus y minus z is equals to 3, minus x minus 10y plus 3z is equals to minus 5, 2x minus y plus 2z is equals to 2, and hence so on. First, to write the augmented matrix is again same, A colon B is equals to. So here we have to make this one 0 and this one 0. For that we applied here row operations. R2 changes to R2 minus R2 plus R1, because here minus 1 plus 1 becomes 0, and R2 changes to R3 plus minus 2 times of R1. After applying row operations, you will get this matrix. So next one is, again we can apply here this one, R3 changes to 11 R3 plus R2, you will get this matrix. So from this we can say here this rank of x minus, from this we can say here x minus y minus z is equals to 3, and from second row we have here minus 11y plus 2z is equals to minus 2, and from this third row we have here minus 4z is equals to minus 46. So from this we can say, from third equation we can say here z is equals to minus 1. Z is equals to minus 46 by 46, it is equals to 1, and second equation implies here y is equals to minus 1 by 11 minus 2 minus 2 z. This implies here y is equals to 0, because substitute here z is equals to minus 1. What we get here after substituting z is equals to minus 1 in this. This is, so it becomes here minus 2 minus 2 minus 2 into minus 1. So it is how much? Minus 2 plus 2 is 0. So this is equals to 0 here, and similarly substitute all the values in this. X is equals to, this is z is equals to, this is 3 plus y is 0, then plus z is minus 1. 3 minus 1 is equals to, you will get here 2. X is equals to 2. Hence we have here x is equals to 2, y is equals to 0, and z is equals to minus 1 is the required solution. Next we have some multiple choice questions. You can solve these questions yourself. This is second equation, and this one is third example, fourth one, and lastly fifth one. You have to solve these equations, these examples yourself. Thank you for watching this video. Thank you very much.